So here's the new Ross Agriculture Docker container. And one of the things that makes Docker a little bit hard to use is if you're going to run a graphical interface for a program and to be able to see that inside of your Docker container. And so this is just using VNC, and then you use your web browser, and then there's an exposed port, and then you can see inside of the Docker container. So all of this is actually running inside of the Docker container. It's not installed locally on my machine. And the other thing that I've been working on is instead of having to type in ROS launch and then a bunch of commands to be able to get the simulator running, just linking these two icons. And so now you can double click the ROS lawn tractor icon and it will start RViz. It will load up the simulation environment, and it will bring up all the packages to be able to drive the robot around. So it does take a little bit to load everything up, but it runs okay once it's up. So now you can choose a 2D nav goal, and you can send your robot on a mission, and it will drive around. The other thing that you can, when you start your Docker container, you can link devices into your container. And so now I have linked just a joystick into the container. So once the simulation is running, then you can come over here and there's a teleop button. And this is basically, all this is ROS launch the Joy node. So, but you can just double click it and it will start. And now you have a dead man. And then if you drive forward, the robot goes forward. If you go left, the robot will drive left and drive around. So that makes it kind of interesting to see. Now, if you want to, you can take a look at each of the topics and the nodes and see the traffic that's going on. But you have a working example of what you should see. And so that may make it a little bit easier to get going. So the one thing about ROS is you can have multiple subscribers and multiple publishers. So this joystick is publishing a command, the command velocity message. And so the simulator is listening for a forward reverse message, which is linear X, and then also listening for turning, which is angular Z. So those are the two messages. But you can also do things in ROS because it's loosely coupled. You can have like a little Arduino Nano, it's like $3, and then you can have a little $5, this is a servo. And this could be used for steering your robot, for example. This is the kind of the ROS challenge that we put out there in the ROS channel. But now you can, inside of this Docker container now also has Arduino software, the IDE to load the software onto your Arduino. And so that should start up here. The one thing you will want to use is you have to tell it what directory, and we're using the sketchbook directory. So once you hit OK, it will load up. This is just a standard IDE. But now under examples, and then if you scroll down through, you'll see roslib. And this is a ROS library which contains all the messages to be able to communicate between an Arduino and the ROS master. So I added another example under the roslib called steering. Now what this one has is the software that you can just download into your Arduino, and it is listening to that command velocity message. So it's subscribed to this topic. Yes, they're really small. There we go. How is that? Is that more readable? So in this, you can take a look. It's in the Docker container, but this is the command velocity topic inside of ROS. And so that is exactly what this joystick is publishing to, the left or the right and left steering, and then forward and reverse. And so it will take in that message. And then from that message, it's listening to the angular Z, which is how we're turning. And then from that, it will send out a command to the servo motor and turn our steering. So this is just a working example, and you can upload this to your Arduino device. Maybe I'll show you how that works. And then once it's loaded on your Arduino and you have your servo, you can run this command or this icon, which is basically connecting your Arduino to the Docker container running ROS. And so now your Arduino is running and your servo is active. And so if I move the joystick left and right, you'll see the robot turning, and then you see the servo turning. So both the servo and the simulator are listening to the same message. Any questions or thoughts on that?
I think that's really good stuff you're doing.
Okay.
I like, it's real basic, but sharing your screen like that, doing the ROS, showing the ROS program is really helpful. I also want to go into the code a little bit, like how the tractor moves around and things like that too.
You wanted to know how it moves around?
Yeah, like in the code, if you wanted to walk through the code a little bit, so you subscribed, the tractor is some kind of an object that subscribes to that topic and gets its signals. Is that, or does it have a path planner first?
Okay, so there's a couple things that were going on. This actually has a simulation. There's a simulator running called Stage. And so what Stage does is it listens to that command velocity message, how fast forward, and then where you're turning. And then it will give out your odometry. It will actually move your, your vehicle around. So it's a pretty simple simulator. And so that's kind of how that works. The simulator takes in your command velocity message, runs physics engine on that, and then it will output your new position. And that's how we see the tractor move in RViz here.
If I remember right, there was another app that a few of us had put into an AWS instance, and that one was using some kind of path planning. Maybe that's your 2D nav goal approach. So you have different modes basically here on how you might control it, right? Because now it looked like you were steering, it was immediately responding to your joystick commands. The other option would be to do the 2D nav goal.
Yeah, so this 2D nav goal actually sends in a goal to the move base, which is the navigation stack in ROS. And so that has your global planner and your local planner. And so you can basically, it's just an X, Y, and yaw, wherever you click down, hold the mouse button down, and then you can drag this arrow around. And then when you let go, that sends in a goal to move base, and then move base will dynamically plan your path there. And if you have an obstacle in front of it, it will move it around that path. So this is all the navigation stack. So they're kind of two different modes, like you're saying. One is just the human moving the machine around, and then this one is the planner.
Okay. Now, if you wanted to add, I think the other week you were adding some plants or trying to add some plants. If you wanted to add a new object in here, could you show how you would add just a simple block or something like that to the screen? To the
Sure.
obstacle.
Yep. So there's two places where that happens. So there's the simulator that needs the object in the simulation so that if you hit it or bump up against it, then the physics engine will say, okay, you crashed into this object and your vehicle will stop. This program that we're using here is called RViz, and that just displays. So that's a visualization. So if you do it this way, if you're looking at RViz, then we use this thing called a marker. Like this is actually a marker in RViz. And then in the simulator, we put this exact same shape as an object. So it's kind of like dual work. The simulator that I was using with the plants is Gazebo, and that's a 3D simulator. But I can show you if you want to markers like um, there's an example of a marker in here. Um, and so if you want to add to the scene, you would put the as a marker. If you this object as a tractor is the URDF model. So let's take a look at um, if I can remember where I found it, where I put it. So this shapes. So this is the shape. Is that readable? I think
Oh
so.
yeah, definitely, definitely.
Okay.
So you would then you can create different objects, different files, right? One file for each different object.
Exactly. Yep.
Okay.
You can create multiple objects. Like if you want to create an orchard, for example, you can just create like a cylinder and then just have multiple places. And then
Uh,
in this position, instead of these being, this would be a variable instead of just a number. And then you could just loop through those and then create those shapes.
okay.
So that's basically you can scale it, what color you want it, what position, orientation. You're basically creating this marker object. And then the way that you, inside of RViz, you need to subscribe to that topic. And there's a marker data type here. And so visualization marker. So you publish all of your markers into this visualization marker topic. And then inside of RViz, you subscribe to this visualization marker topic, and then it puts them inside of your world. There's a good tutorial out there on the Ross Wiki on markers.
Very good. Yeah, that's helpful to have an expert while you're looking at it. That's good. Appreciate it. The other question I was going to ask related to the software is I know that a few of the folks on these calls have been working on the lawnmower, the physical lawnmower itself, and different components of that. Do you have the ROS software somewhere and the GUI that would be used to drive that lawnmower? It seems like it'd be different than what you're showing on the screen here, or is this the code you're planning to use to drive that lawnmower?
So this is the code that we use to drive that lawnmower. So
Okay.
Yeah, what's inside of Ross? So it goes back to that kind of that loosely coupled publish and subscribers. So you have something publishing that command velocity message, which is telling your robot how fast to move and where to turn the steer angle. On your robot side, you just listen to that command velocity message. And so this joystick package that we're using that's in the simulator is exactly the same one that I use to drive my robot around. This planner that's in here that does this is a little bit different than the one that I use on the AgBot. On the AgBot, I was just using a pure pursuit. The reason um, the reason why this is different is because right when you click a goal, this is dynamically generated, this path. And so it's hard to send in a predefined path. And at the AgBot challenge, the goal, what we were doing was just driving up and down corn rows. And so we had to have a predefined path, and then you send that predefined path into the planner. Now, Move Base Flex will allow you to do both dynamic planning and also send in a path, but we didn't get that working in time, and so we just used the Pure Pursuit controller. And so we generate a path, and then the Pure Pursuit controller just drives us along that path. So there's no dynamic planning, no global planner or local planner.
Gotcha. Okay. Okay.
This is using the TEB local planner, TEB, and people like that are getting good results.
It seems like there's a concept where you would instead of controlling the tractor with your joystick, like you were doing, there's also a second, there's many different modes you could run in, right? So another mode would be you set a position with your joystick and you control that, and you would just be a few steps ahead of your tractor at all times, and then that way you could go ahead of the tractor rather than being exactly right where the tractor is. So it's kind of a combination of the two things you've demonstrated.
Sure. Inside of Ross, you can like on the cell phone app, they just have like a slider. And so like if you want your robot to go a little bit forward, you just move the slider forward. And there's also inside of RQT, you can go to robot tools and then robot steering. And this gives you just like little slider bars. And so you can just run this on a web page or the cell phone app for Ross. But basically, you just if you want to go forward, you move this slider a little bit forward, and then the robot starts moving there. And if you want to turn a little bit, you can just move the slider around.
There's also some
Very good.
There's also some good plugins. Um, there's some software that you can just use joysticks directly or keyboard control, which might be a little easier than the sliders.
So we use this robot steering for tuning and testing and driving around, or with the joystick if you're out walking.
Okay. Yeah, good. Well, I won't ask too many. I won't hog up the whole evening, but that's the kind of stuff I am still trying to figure out. So appreciate it.
Yep. What else are you working on, Alan?
Yeah, like I mentioned last week, I'm getting some pieces put together for a greenhouse for the winter, a hoop greenhouse. And so getting that going, and then doing a bunch of finalized testing here. I think I mentioned I'm using a small gas-powered generator, electrical generator to power the rover when I'm not inside. And so I've tested that and got that working well. And so pretty well waiting for some nice weather and side. So maybe not next week, but the week after, I'm hoping to have some video or something I can share with you guys.
Awesome. It's fun. Jeremy, what's new? Anybody have it?
Sorry. Not much. At work, just doing some Docker stuff for converting old build processes from a standard install to Docker containerized builds. So makes it a lot easier.
Are you using make files to build your Docker containers?
Not make files. I'm just using we wrote a script. I modified the script for this new thing, and then I've been updating the Docker file to add the correct dependencies. So that's pretty cool. I like Docker. Makes the world a lot easier.
So like, since I've been building this container, you know how so as each run command, it stores a snapshot of that container. So if you don't make any changes before a certain point, then it doesn't have to rebuild.
Yeah.
But it kind of leads to like weird Docker files, because I don't want to go and edit anything prior. So I may do like install a few packages and then I forget one, and then I'll just do a whole new install down here instead of,
Oh yeah.
because I don't want to go back and have to rebuild all the other containers.
Yeah. So it might be a little better to kind of start doing that through Docker files, because you can establish the basis for that. I'm pretty sure on Docker Hub, I don't know if you can sign up for private registries. We have an internal, at Honeywell, we have an internal server to manage our Docker images. So I don't have to go to Docker Hub, but that makes it useful. But I'm pretty sure on Docker Hub that you could say, build kind of a base image and then create Docker files from that, and just kind of keep expanding it. Might help you, and a lot of people keep those Docker files in a Git repo, and then you can correlate. What I like to do is correlate the tag of the Git repo with the tag of the Docker, and I think that's pretty common practice. So if you go out to Docker Hub and do a pull for ROS, for example, you might do a Docker pull ROS : kinetic, what's it called? Kinetic base, kinetic, I want to say ROS base, but anyway, I forget the exact tag name, but you basically know that that's the latest kinetic base tag. And then if you go out to OSRF, if you go to the Docker Hub, it's OSRF/ROS. They actually have full the desktop full builds that you can run, and it uses the xhost command, so you can it has all those RViz and all that in the container, in the image. So when you start the container instance, you should be able to run RViz out of the container, and that is really powerful. They don't have them yet for ROS 2, but that is the full desktops, but they do have all the ROS 1 stuff, so you might try that.
That's interesting. I didn't know. That's a good idea. So you said when you check in your Docker file, you take that and you put that into the tag of when you check it into Docker Hub.
Yeah, so and you can do that locally. So there's several things to consider here. First is starting a good repo on GitHub that's your Docker. And when you create a version, or let's just say you have a hash or latest or whatever tip, that or the head of a branch, then you could use that as a Docker tag in some CI process.
Okay.
Continuous integration. So you could that. So that would be the source of that image, and then you have your CI process produce the Docker image and store it in Docker Hub, say. And what I'm just saying is that it's good to have, if you start doing releases of that Docker image, you have like 1.0 or 1.1 or 1.2, that the tags in Docker Hub would make sense to me to make those tags the same. That way you know what the source of that is. And then for your case, where you find yourself going back and forth to try to figure out what dependencies you want to install or uninstall, you have a basis, assuming you keep like a change log or something, you can establish what was, well, even if you don't, the Docker file basically shows you all the apt-gets that you ran to build that image. So that's I find that very handy to manage.
Okay.
And then there's to get to Docker Hub. I haven't done Docker Hub, but I'm pretty sure it's the same as what we do internally. And there's a Docker login where you provide login credentials to the registry, and then you can do push-pulls from, or generally pushes to that registry. But I think there, in like robotics, there's some of these fundamentals, these things that help you accelerate your efforts, and definitely Docker is one of those. If you can spend some time learning Docker, it's going to make your life easier, because you can try out whole new dependencies with not much effort, as opposed, like in the old days. I don't know if you remember, like
Image your machine.
yeah, we used to. I used to build new machines over and over. I'd have like a USB key, and like probably 3 times a week I was imaging machines oh, I screwed up that dependency, so now I got to reinstall everything. It's just it makes it a whole lot easier to manage.
Norton was the tool back in the day.
Yeah, we use Clonezilla
Okay.
to keep track of images, but yeah, there's all kinds of imaging tools. So that's what I'm up to.
That's fun. That's good. We'll those questions we'll have to put. We do have Ross Agriculture has a Docker Hub, and we've had 35 people pull down our ag simulator. But when I get ready to build this new one, maybe I'll shoot you an email and have you take a look and see if it's
sure.
technical difficulty.
That's what I was wondering.
Back. Yep. Walter, what's new down in New Zealand? Are you in listen-only mode?
Yeah, still lots of testing and driving of the vehicle. And so we have put a mulcher on the front of it. I'm not sure if that's the right word for your guys, whether you So it's basically the prunings of the grapevines, getting all mulched up in the vineyard. So we built one of them, put it on the front, and it weighs about 450 odd kgs, and we had some difficulty getting the hitch to hold it, but we managed to do that so we could turn at the headland. But yeah, it ran really well. It's quite hungry in regard to power. It's probably pulling about 30 odd kilowatts. And the problem that we found was that it shifted the center of gravity of the machine dramatically, probably put it another 350 mil towards the front. And that was fine when we were going down the road, but when we tried to turn at the end of it, it screwed up all our turning.
Yep.
So we're obviously the pivot point of the skid steer had changed and all of that. So we had to work our way through that one.
You're able to fix that?
Yeah, we fixed it very crudely by adding some weight on the rear of it, and it went better, but it wasn't nowhere near perfect. But we do know that we do have some lazy steering on the transmission, and the hydrostatic pumps. We think we've got something like 700-800 millisecond lag, and so and that's going through the CAN bus, and we're not sure where the lag is being generated from, whether it's from the guidance controller or in the CAN system itself. So we've got to work on that to see where that lag's coming from. We always knew it was there, but we sort of disregarded it because we were steering okay.
Mm-hmm.
And but it really surfaced last week. So
You said there was 600 millisecond delay?
yeah, something around there, yeah.
Wow.
So obviously we're saying go right, and it's thinking about it and then saying, oh yeah, okay, we'll go right.
Yeah.
And I think one of the guys said it's like an analogy was it was like trying to turn a steering wheel with a bungee cord with a piece of elastic, you know.
Mm-hmm.
So yeah, we've got to work out where that delay is coming from. My guess is it's in the CAN bus because we seem to be loading the CAN bus up dramatically. It seems, you know, sometimes I think we've seen figures of 78% or something loading on the CAN bus.
Do you have multiple CAN buses?
Yeah, we have two, yeah. Three, sorry, yeah.
Okay.
I'm not sure what the software guy's doing in that regard. So that's one of the avenues that we've got to go down.
Yep.
So, I'm not sure how the CAN bus system actually works, Matt, to be honest. I don't know. I mean, I know that we're using, you know, again, we're using an IFM IO block to drive the valves, and that straight CAN bus is straight to current out pulse width modulation on the current output. So I'm not sure whether it's coming from that IO block, whether it's coming, as I say, from the guidance controller, or it's the CAN bus system itself. So the first thing that we do is isolate the CAN bus. So this week we're putting in just an analog driver, so we can drive the valves straight out of the guidance controller straight into the valve itself. Get rid of take out the CAN bus, see whether that is the fault, and if so, we just got to work out where it's coming from and get rid of it, basically. But no, everything's working okay. I mean, the driving was, you know, straight line stuff was good. You know, we managed to get back in the rows, although we looked like a drunken sailor doing it. It still got in there, which was a bonus. But yeah, it looked okay. It really mulched really well, and the job that it was doing was remarkably good. So that's all good stuff. So there's a whole lot of more development work that we've got to do now. We've got to get the mast in the middle of it. Put this other blower unit on the rear of it. So it's getting heavier and heavier and heavier. And then we got 1,000 liters of spray tank that we've got to get on it as well. So
Yeah.
that's another ton. So we'll see how it goes then.
Yep. Mounting that tank in the center of your vehicle.
Yeah. Hopefully, it's all going on both sides, which is basically straight over the top of the tracks.
Okay.
That's the theory, but it's starting to load up quite a lot. I think now that if we've got another ton of water on board or spray on board, we're probably looking at we're going to be close to 4.5 ton, I think, all up. So it's a beast of a machine.
Well, still.
Yeah. Did you put this on a regular tractor?
No, we built our own, Alan.
Oh, do you have any pictures?
Yeah, but I can't really share them at the moment. It's still under sort of some non-disclosure stuff from the client.
Oh, gotcha. Okay.
But it's getting there. I mean, if we went recording, I could show you something, but now that we're recording, we'll have to leave it till we come in early one day or something. It's got some videos there to show that. I think the client.
Are you using Ross, or you're still exploring?
No, we're not at the moment, Alan. We're still exploring that avenue. I'm trying to get the software guys to look at it, but they're reluctant to jump horses at the moment, which is fair enough, I guess. I mean, we've got something that works at the moment. I think they're a little afraid to change and then have something stuff up on them,
Yeah.
But,
I know Matt would like me to switch too, and I'm still exploring, still watching, so still listening.
I think it'll come though. From where I'm sitting, I just make sort of recommendations to the software guys and saying, listen, I've heard about this. Go and have a look at it. See what you think.
Yeah.
So just a gentle nudge in that area. It'll probably pay dividends in the end. I think software guys are a funny bunch. We have to tread carefully with them. They tend to get their nose out of joint pretty quickly. From my experience, anyway.
I'll add a thought on switching to Ross. So the thing is that a lot of times when you're trying to create custom robotic architectures, you're trying to reinvent. Essentially, you're paying money to develop things that have already been developed for open source, and the cost driver to switch soon. You get to the point where you think, oh, well, I can do this easier. It seems like it's a short distance to get to where you're going. But in the long term, you end up paying a heavy price because there's also code maintenance and a lot of other factors that are going to weigh you down in the long term. So my suggestion would be to maybe take a day or two pause if you can, or even a few hours, and have a look at what it's about, have a sit down and go over it, because ultimately, if you're paying money or somebody is paying you money to develop, you're competing against the Ross community, and it's growing. It's got a lot of strength behind it. it's become a de facto standard. So if you're not with it, you're competing against it, and that's in some cases money wasted, I think.
Yeah, I tend to agree, Jeremy.
Yeah.
It's like that's why I'm on these guys' cases probably every week to look at different things, and I'm a big fan of not reinventing the wheel, and I'm a big fan of learning from other people's mistakes. So I mean, anything that we can do to avoid that has got to be good. So that's, I mean, I can't tell them what to do because they'll, as I say, they'll get their nose out of joint, but I can push them in that direction.
I would start just by asking them nicely to peruse the last couple of years of ROSCON talks, because there's a lot of great information coming out of ROSCON, and so most of those are on Vimeo. Is it Vimeo? Yeah. And also if you just do ROSCON 2017, ROSCON 2018, you know, they have and even 2019. I don't know if I think the program's out, but not obviously the talks and the presentation material aren't out yet. But you can go out there and look at like the last 5 years of talks, or even do ROSCON, whatever your problem is. Like if you're trying to do a planner, you might do ROSCON planner and see what happens, because they might have a good presentation. Of course, there's a lot of other good presentation material, but I'm just saying, you know, it all starts. Yeah, that's the one we went to, right, Matt?
Yeah.
Someone and I went to 2018. So, but there's a lot of material out there that it only takes like most of them are 10 to 30-minute talks, and they're pretty interesting. Even if you don't use ROS, there was one in 2018 that I hadn't heard about. I'm forgetting the project, but there was maybe someone remembers, there was a talk about this recording. It was basically you could record GDB events and play them back. It's kind of like a ROS bag, if you've heard of that, but it was for discrete events, so asynchronous events. So you could like, you know, it's kind of like doing breakpoint debugging, but the whole, you know, recording everything. So it was, I have to look that up, but yeah, that wasn't at all related to ROS, but it would be incredibly useful for debugging.
Yeah, it's funny that you mentioned that, Jeremy, because one of the things that I've asked the guys to do was, I think it was Friday, I've asked them that, so we need, because of this problem with the steering and the delay and the steering, and I've asked them to get me some data that I can look at to find out, you know, what is actually happening. And so what you've just mentioned there would be really, really useful if we could, you know, get the telemetry off it or even log it on board, and then plot that out later. I mean, I think that's what you were talking about, Matt, early on with Ross Bag and that RBQ or whatever it was.
RQT, yeah, and RViz, yeah. So the ROS bagging is huge. Like I can't speak enough about that. A trick I've learned recently is ROS Bag Record now has a feature called max splits, and then you can split on different criteria like time or size. So imagine this being like a black box recorder where all the messaging you're recording. And the way I've recorded it is you can create what they call a RAM disk, or it's a file system you mount from the RAM. So it's high speed. It's not actually going to an SSD or a spinning disk. It is very low latency recording, and you can keep it you can keep it in a fixed size recording by doing the splits and max split. So what I've done is started the recording as soon as I start my bot, set the max splits to say 3. So that's 3 splits. And then each split was like a minute. So I record everything in up to 3 minutes of history. And every time it hits the 3-minute limit, it'll roll over and get rid of the last one, which when you so when you have a crash, when you're recording that messaging and you say, oh, something went wrong, you just, save those bags, and then you can play them back and look at the timeline. You can look at all that. Very handy.
Yeah, it's certainly something that we've got to do, because it's no good looking at the machine and trying to analyze it. You need the facts and figures of it. I'll ask them to do some recording on the pressures to the track motors, the speed of the track motors, and pressure of the pumps and stuff like that, just so I can look at it and say, well, categorically, that's where the problem is, because it's being told to move. It hasn't moved for that amount of time, and it's taken so much pressure to do that. So those sort of things would be monumental in trying to understand exactly what's going on with it.
So for your CAN bus problem, what is your, what's the device that you're running? Is it just a standard PC, or is it some kind of specialized embedded hardware, standard operating system? Do you know any of those?
Unfortunately, no, Jeremy. I don't know enough about that side of it to answer that. I could take a stab, but it'd probably be a lie.
Okay. Well, maybe if you have some specific questions, have them post it in the Slack channel, and maybe somebody in the community can help clarify some things if they get stuck.
Yeah, that'd be cool.
The other thing is, if you're talking about switching to ROS, is pick one little simple thing. You can still have your full system, but just pick one little piece of ROS and use that.
So we got some young students that are working on path planning and telemetry and the GUI side of things, and so we maybe one of them. I should have a talk to them, maybe do something on that, and let them concurrently work on that with the ROS, and let the main software guy continue to do what he's doing. Might be a way around it.
Or invite them to.
Yeah. So you.
Yeah, exactly, Jeremy.
If you got a web guy, if you can grab some data off your vehicle with ROSBag, you can use ROSBags, and it won't impact your system. I mean, you could just put a ROS node on your CAN bus and then collect your CAN bus data. But there's also WebViz, so your GUI guy may like to play around with WebViz, and you can start visualizing some of that data that's coming off of your vehicle. And that would be a real easy one. You just connect into your CAN bus and then use ROSBags and record your CAN traffic, and then you can play it back. And you're not interfering with your system or adding complexity. It's
Yeah, I think that's what we want. I think we wanted something to run alongside it and make sure that if we can get that data back and have something concrete to play with, to visualize anyway. Because at the moment we're sort of, I'm sort of grasping at straws really.
Yeah.
There's nothing And there's nothing factual about this. It's all the way in which I feel.
Yeah, I've spent hours working on ROSBAG files. I mean, you record it. It's amazing how valuable they are. You can play them back and relook at things and go back. But if you're out on the vehicle, you may have can sniffer and it's cold and windy and the lights on your laptop, you can't see anything. But if you can just record the process and what's going on, then sit at your desk, play it back, step through, reverse, like you can just, yeah, it's handy.
I should start talking to these young guys and get that underway.
I also record a camera. It's nice to record a camera so I can see kind of the environment. So like if you're going to record your CAN bus, that's good. But maybe, I don't know what would be useful for you, but
No, I thought exactly the same, Matt, because it'd be, we got to know, we got to try to correlate where we were and what happened at that particular time. I mean, one without the other is probably not really worth it. Although, you'd still be able to see what the variations are. But it'd be really nice to have a visual as well of exactly where you were at that time, what was in front of you, behind you, or beside you, and then what happened to the machine at that particular time.
yeah,
So,
as I'm going into the turn, then I want to see what was the signal to make that turn and how fast did it respond, and then I know, okay, yeah, this is what was. I am turning or I'm going straight. Little things like that. Having a camera is nice.
yeah, well, one of the things that our turns have never been very, very nice. I mean, they've always been a little bit skid steerish. Even though we're running a skid steer machine, my understanding of the way in which a normal person would understand skid steer is that you would have one track running forward and one reverse, and that gives you a very big. That's your skid steer. So what I'm trying to do is to run those two tracks at variable speeds to give us a nice turn without too much disturbance to the ground. Although we're still going to get that, but just to get a nice radius curved turn, So and we still don't have that, and I'm pretty sure it's all still to do with the steering control. I think if there is a PID in it, it's doing a very, very bad job.
That's a challenge. I worked with skid steers for a couple of years.
Did you get the turning nice?
No.
No?
No. We got the load problem. So like I had put a bucket on there, got it all tuned. It was driving great, and then put a bucket on there and grabbed a load full of dirt, and then wouldn't drive anymore. So I got these concrete, like it was 1,500 pounds. And so I tell the control, I don't know how any of this stuff works, but I was working with the controls guys, and I was like, okay, here's a situation. I'm going to put a 1,500 pound concrete block in this bucket, and we got to get it to drive straight and turn, and then take it out, and then still have it, because I had like a fixed attached sprayer, one of those electrostatic sprayers.
Yeah.
So when you go up and grab that tank and it's all filled up, then like you're saying, your skid steer weight changes and that where it's turning. So that's real.
Yeah, it's real. It's I mean, we went from just having the what's that, like 1,000 pound, I suppose, on the front with the mulcher. It was just all over the place. But we still sort of had control of it, and it was quite amazing that the control system still had a modicum of control because we were able to get back in the road. But during coming out of the row to getting into the row, it was like, whoa, what's going on?
Yep. We were getting ready for a trade show and found that problem about 3 days before or a day before, I don't remember, but a couple of guys there are awesome and they jumped on it. Jeff Farron and John Peterson cranked on that.
I was watching a Farb guidance video the other day, and they're running Caterpillars, front end loaders, skid steers, and their tuning's quite nice. So it's possible. But I don't know if they're cheating or not, but looked okay to me.
Yeah.
And I can get on the remote and do quite a nice turn as well. Although that's been slow as well lately. But yeah, so I think it's possible to do all this stuff. It's just a case that just going to be time and a lot of mucking around, I guess. That's fine.
Yep. It's a hard problem.
Yeah, well, if it was easy, everybody would be doing it, Matt.
Exactly. You're on the frontier, Walter. You know, like,
we're the only idiots around, I think.
yeah. Awesome. Well, we're coming up on the hour. Is there any other items to cover for tonight's meeting? Alan, Sowen, Jeremy? All good. All right. It's good seeing everyone.
I would just like to mention that, piggybacking on Jeremy's point on ROSCON meetings being really informative. When I attended ROSCON, I didn't know half of the stuff that I listened, but just being able to listen to those things. And now when I connect those things to real world, like when I try to do things, sometimes things come up and I remember this particular talk that I had thought, and I have something or some starting point to get researching and do more into that topic. So I think those are really valuable, and yeah, I think it's just great. And it's really hard to get back and go through those videos. But so I would, this year I'm planning to watch it as it occurs. And even though if it might not seem like it's, I would get much out of it, but I would still, listen to some things and know the gist of the topic. And I think that would be a good approach. But yeah, just a thought.
Good point. Awesome. Have a great week, guys.
Thanks.
Thanks, mate.
Mhm.